X is not a car rental company, and man is not a truck maker. So that's two things I want you to learn. Instead, man is actually a very old company. It's been around since 1783, but for the last 35 years, it's been focused on asset management, alternative asset management. So we're kind of a large-ish alternative asset manager, and we do lots of solutions and bespoke strategies and all sorts of multi-strat stuff, and a lot of it's quant. And so we use a lot of leverage because a lot of hedge funds, and it's alternative asset management. So we're looking to provide different returns to our clients. So to do that, we use a lot of data and make a lot of decisions about what derivatives to trade. So we trade a lot. So the $175 billion of assets becomes $6 trillion of trading. So it's not as much as like an exchange or a payment platform, but it's a good amount for an asset manager. And then we have all these markets that we trade, and we're using all this data, and we're doing all these different kinds of strategies. And that creates this kind of problem of scale. So we do a lot of technology to support that. You're going to hear about how we use Aeron shortly. But we also, like in the research and quant space, are using a lot of Python and data science tools. And that's where we really got into the open source. So we have been supporting Python, particularly open source stuff, for like a decade now. We've made a few projects like Arctic and Detail and Notebooker. So if you use Python to do your analytics on your stuff coming out of Aeron, this might be interesting to you. Because we've been doing it for a decade, we've made some good progress. With some of the other sort of open source leaders in finance, we're up there. And we've been sponsoring things like the Python Data Science Meetup. And it's all worked out really well. So I definitely encourage, everyone to get involved in kind of supporting open source. And we're all using a lot of it now. The ArcticDB story is about a decade long as well. We were looking to kind of replace some of the proprietary databases we were using for tick data at the time. Weren't really happy with them. We wanted something really accessible in Python that was really good for large data frames, data sets. So we built this kind of first version. It was in pure Python. We spent time finessing that. It's now C++ backed, and it's has petabytes of man group data in. All the alternative data, but including tick data and all the data we're generating from execution and things like this. So we're really excited about it. Kinds of reasons we're excited about it is because it's optimized for huge data frames, so billions of rows, possibly hundreds of thousands of columns. We've got one user with 1 million columns in a table, so it's really wide data sets as well. It's really good at sparsity and handling annoying financial things like markets going away or new bonds being issued. So the raggedness of data, and it just versions by default. So everything's recorded as new versions, and there's an architectural trick there that achieves that, which is that we kind of built it on immutable data structures. And we built it without any database service layer. There's all the database logic happens in the client in the Python library, which is rather unique, we think. And so we've got this so we do that by having these immutable data structures stored on this fast flash storage on-prem. And it lets us change it incredibly rapidly without any coordination. And so here, this is doing 30, 40, 50 gigabytes per second during a couple of days, an average week. Serving up to our Python research cluster. And so this is something if you've got 40 gigabit networking, this is 8 or more of those fully saturated. So it's lots of data science going on. So it's a kind of a cool thing we're really proud of.